Okay, now we're going to look at 4.5. So let's give a try to it. So in 4.4, we had learned what a polynomial is, and we had learned how to add polynomials, and that's something we had actually done before. And now they talk about how to multiply polynomials together, and actually it's something that you've done before, right? And the reason I say that is because they had showed us how to, in 4.2, I guess, they had showed us how to multiply 3x times 2x, right? So a monomial times a monomial. And how they said to do it, I guess it was 4.3, is they said to multiply the numbers together. 3 times 2 is 6. And then with the exponent, with the variable, you added the exponents. 1 plus 1 is 2, x to the second, right? So that's how they told you to do it. And now they're going to use that, right? So they showed us this in 4.3, right? And now they're saying how you multiply this times this monomial times this binomial is you just use the distributive property. So you're multiplying this times this, which is 3x, times 2x, and then you multiply 3x, so it's minus, and then 3x times 7, right? And then you just do the numbers. So that's 6x, 6, 3 times 2 is 6, and then x, this is x to the 1, and x to the 1 is x to the 2, right? Adding the exponents. That's the product rule that they showed us in 4.1, right? And then minus 21x. And then nothing more can be done with that. And so those are not like terms, so I can't subtract them. Can only subtract these things if this was x to the second and this was x to the second, or this was x and this was x, but they're different. X to the second is not the same as x. And you would write them in descending order, which they are written in descending order here. And here, this is a monomial, so this is a single term right here. Monomials are glued together with multiplication. So this is 3 times a to the second times b. And then this is a trinomial. Trinomials are glued together with addition, right? So there's an addition. This is a monomial right here. And here's that addition that separates the 3 pieces, right? So I'm going to multiply this together by this. So how you multiply, they told us in 4.3, is you do the numbers first, which I only have a number out here, so 3. Then you do the variables in alphabetical order, so a to the second times a to the third, and then b. And then I want to put this together with the product rule. You add the exponents. 2 plus 3 is 5. 3a to the fifth b. And then you're going to do the next piece. So the number comes first, the sign positive, right? Positive times a positive. The number, the a's, a to the second and a to the second, and b to the second. And remember, this is b to the 1, right? That's b to the 1. And so here, when you add the exponents, that's 4. And you add the exponents using the product rule, that's 3, b to the third. And then the next piece, a positive times a positive is a positive, the number 3, the variable a squared, then the b's, b1 and b3, right, 1. And then product rule here, add the exponents, b to the fourth, so plus 3a squared b to the fourth. And mostly people won't show that. They'll just go right to this, and that's perfectly fine, but it might take you a bit to get to that, right? And so if it did, remember how you write them. You multiply the numbers first, then alphabetical order the variables. Okay? Then they talk about multiplying a binomial times a binomial. So this is a binomial, and that's a binomial. And they say that how you do it is by FOIL. And FOIL is an acronym that means do the first, then the outer, then the inner, then the last. And I'm going to show you, and it's just a pattern. I'm going to show you the pattern, and that pattern is the distributive property twice is what it is. So you multiply the x times this x, and they call that the first. So that's x times x. Then you multiply here the x times the 5, and they call that the outer because these are on the outside of the parentheses. So a positive times a positive is a positive. And then x times 5, well, you write the number first and then the x second. And then see how I've used the distributive property with the x. So I'm done with the x and I move on to the 2. And this is called the inner because see how both of them are on the inside? So a positive times a positive is a positive. And then numbers and then variable, 2x. And that's called the inner. And then last but not least, a positive times a positive and 2 times 5. And I wrote out what you're going to multiply. So you can put a times here if you like, put a times here if you like. So you multiply those together, you get x squared. These are done, right? But do you notice that these are like terms? So I can add them together. And when you add them, they have to be the same variable. Then you add the numbers and you attach the same variable. And you have to say that to yourself until you stop multiplying. Because the most common boo-boo that people make is to tell me this is 7x squared. And that is a boo-boo. It is not 7x squared. What you did was you added the numbers 5 and 2 is 7, but you multiplied the x's. You said x times x is x squared. But it shouldn't have been. It should have been adding. When you add them, you add the number coefficients together on things that are like, and you attach the same like part. And so this is just 7x, and then plus 10. And then I'm all done. And so that's FOIL. Everyone loves FOIL. It's their favorite F word. So we're going to try this one. Going to FOIL it. So first, x times x, right? X squared. And you'll get where you're really used to that, and you don't have to write it out. X times x. You'll just write x squared. And then I'm going to multiply these together. And it's a positive times a negative is a negative. And the numbers first, 6x. And then on the inside, positive times a positive is a positive, and then also 6x coincidentally. And last but not least, a positive times a negative is a negative, and then 6 times 6 is 36. And notice that the outer and the inner, and those are usually like terms, not always like terms, but they are a lot of times like terms. So not always, but a lot of times. They are like terms and they make 0. So we just get x squared minus 36. Later on, they're going to tell us that this thing here, x squared minus 36, has a special name. And so should I tell you the special name now, or should I tell you the special name later? What do you think? Well, its special name is difference of squares. So it's called a difference because it's a subtraction. And it's called of squares because this is x squared and that is 6 squared. 36 is 6 squared. So it's called a difference of squares, and a lot of books, including our book, and people singing songs call it a DOS, is what they call it. And so anyway, so that's that story. And we'll be seeing more of the DOS, the difference of squares, as we go along. Okay, so here they're asking me to multiply this together. So I'm going to FOIL this. So remember the numbers together. I'm going to write this again first, and this is 2x times 3x. So in my mind, I'm thinking 2 times 3 is 6. And x to the first times x to the first, add the exponents, is add x to the second, right? That's the product rule, right? And then I'm going to multiply these together. That's the outer. And it's a positive times a positive is a positive. and then 2x times 4, right? But you do the numbers, which is 8x. And then on the inner, we're going to have a negative times a positive is a negative. And the numbers are, I mean, this is 1 times 3x, right? So it's 1 times 3, right, which is 3x. And then I'm going to have the last but not least. And that's a positive times a negative is a negative, and 4 times 1, which is 4. And then notice again that a lot of times the outer and the inner, right? The outer and the inner are like terms. They're not always like terms, but a lot of times they are. And so since they're like terms, I can add those together. 8x take away 3x is 5x. And so this is 6x squared plus 5x minus 4. It takes practice to not multiply when you were adding and not add when you were multiplying. And these problems here, multiplying a binomial times a binomial, take that you can multiply and add or subtract, you know, and so you have to be able to do both. Anyway, and it takes practice. And pretty soon, people who practice get good at it. And so we'll give a try to this one. Here we go. So the outer, it's got some fractions, right? So, the first, I was already doing the outer, is the first, right, is 4x times x, which is, add the exponents, 1 plus 1 is 2, 4x to the second. And usually people just think this, they don't write it. And then here, positive times a outer, a positive times a positive is a positive, and 4x times half. And all we're doing is 4 times half. And so, and you can do that on your calculator. Like if your fractions are, and it's good to practice with your head too, but 4 times half. So my calculator, 1 divided by 2, 4 times half, right? And is 2. So this is 4 times half is 2, and then the variable goes last, right? 2x. Then the inner, minus 3 halves, x. Then the last, a positive times a negative is a negative, and 3 halves times 1 half. And again, you could do that with your calculator if you like, but that's 3/4, right? So this is minus 3 halves x minus 3/4. And you could do this with your calculator because those are like terms. But me, I'm thinking 3 halves is 1 1/2. 2 take away 1 1/2 is half, right? And so, but you can certainly put it on your calculator. Calculator doesn't do the variable x or the variable x squared, but it will do the numbers. 2 take away 3 halves. And 2 take away 3 halves is 1 half, as suspected. So 4x squared plus 1 half, x, right, attach the same variable, minus 3/4. And there we foiled that together, and we combine like terms. And this is more multiplying. This one is a binomial times a trinomial, and it's the same pattern as FOIL. It's the distributive property. You start here and you multiply a times a to the second. I'm going to write that out, a times a to the second. And then you multiply these together, and plus 2 times a, right, times a. And then you multiply these together, plus the number goes first, 3a. And then I'm going to go on the inside, and I'm going to multiply those together, and I'm going to get plus 5 times a squared. And here I'm going to get plus 5 times 2a, and I'm writing what I'm thinking, and then I'm going to go back and I'm going to clean it up, plus 5 times 3. So here, this is, by the product rule, you add the exponents, a to the third. Here, this is a to the 1 and a to the 1, so by the product rule is 2a to the second. This is just 3a. Then I have a friend, 5a to the second. You can see that it's friends with that. Here I have 10a and plus 15. And usually people just think this. They don't write it, they just think it. I went ahead and wrote it out. You get where you don't write it out. But I do have some like terms to combine. Oh, I have my colored pencils for like terms. And so right here and right here, right? And so that's 7a squared. So a cubed plus 7a squared. When you're adding, you attach the same variable part. So if you're thinking, shouldn't that have been a to the fourth, then what you've turned into doing is you've turned into multiplying a to the second times a to the second is a to the fourth. But when you add things that are a to the second, you add their coefficients and attach the same variable part. 3a and 10a is 13a. So plus 13a. Notice I'm writing it in descending order. A to the third, a to the second, so degree 3, degree 2, degree 1. And then last but not least, plus 15. Do you guys remember what degree the constant is? Yeah, it's degree 0. So this term has degree 3, degree 2, degree 1, right? There's a 1 there. Degree 0. This polynomial has degree 3, the highest one. When you multiply three things, we're all done. That's it. Right? There's our answer. I'll circle it. Okay. When you multiply three things together, and so that's what we're going to do here, is multiply those three things together. You do any two of them at a time, and then do the other two. And it doesn't matter which two you do first. So just so that you can see, I'm going to just do an example with just some numbers. So I'm going to pick different numbers here. If I was asking you to multiply 5 times 2 times 7, it's your choice of whether or not you do 5 times 2 is 10, and then 10 times 7 is 70. Or if you do 5 times 7 is 35, and 35 times 2 is 70. Or if you do 2 times 7 is 14, and 14 times 5 is 70. No matter how you do it, you just do them two at a time. Now, usually I don't feel like I did them two at a time when I have numbers like this. I usually can kind of do it almost all in my head and think I just did it in one swoop. But when you have a binomial times a binomial, it's a little bit more work to multiply it together, so you'll definitely know that you did it, right? So I'm going to multiply these two together first, and if you're saying I would have done the back two first, I'll say to you, it doesn't matter. So you do whatever. You multiply two of them together. Do whichever two you want, just like we did here, right? So x times x is x squared. X times minus 4 is minus 4x. Minus 3 times x is minus 3x. So notice I'm doing FOIL. A negative times a negative is a positive. 3 times 4 is 12. And when I combine the like terms in the center, I get x squared minus 7x plus 12. And I'm going to multiply that by x minus 5, because I haven't done that, right? So I said I was going to get the result of multiplying these together. There's the result. And I was going to then multiply the result times x minus 5. So that's what I'm going to do now. And so I have 6 more multiplies to do, right? This was 4 multiplies. When I do this, I'm going to have 6 multiplies, and I'll have a whole bunch of like terms to combine. So let's see here. X squared times x. So are you guys ready to say that's x to the third, or do you need to write it? X squared times x. So depending on who you are, you might need to write it and say to yourself, oh, you add the exponents, that's x to the third. So I did this, right? And then I'm going to do this, which is minus 5x. And now I'm done with x to the second. And so I'm going to move on, and I'm going to multiply with the negative 7x. So that's what I'm going to do next. And I'm going to distribute it to these two. So negative 7x times x. Do you know what that is? Negative 7x squared, right? X times x is x squared. You add the exponents. 1 plus 1 is 2. Negative 7x times negative 5. So a negative times a negative is a positive. 5 times 7 is 35, and then times x. And I'm seeing some like terms, right? Then, now I move on to the 12, right? Now that I've done that, and a lot of times I'll write it over the top, but it absolutely doesn't matter. Some people are like, why do you even underline it? You're going to multiply that times that and that times that. Well, I underline it to make me feel like, well, that's what I'm going to do, right? So this is a positive times a positive. Here I made a boo-boo, didn't I? Let me start again. Did you ever make a boo-boo before? And I was thinking to myself, I thought that should be x squared. And then I didn't have it though. And I don't know why I didn't. It was a carryover error. So I multiplied these together and I added the exponents. I got x cubed. I multiplied these together, and for whatever reason, I got a boo-boo and avoided the boo-boo just barely, right? This was on my first, I'm going to underline that in green. This was on my first pass. I got this, right? Then here I went on a second pass with this one. So I multiplied there, I got negative 7x squared. And I multiplied here and I got positive 35x. And that was on my second pass. Negative times a negative is a positive. 7 times 5 is 35. And then I'm going to do the blue, the last pass, here times here, right? Here times here, here times here. So let's see, that's positive 12x. And is it minus 60? 5 times 12? Is 5 times 12 60? I think it is. That's one of the ones that I guaranteed myself I had memorized. I think I have it. My uncle used to tell me that you need to know, I don't know why, but you need to know up to 15 times 15. And I strive for that. So now there's like terms, right? And so here I have x to the third. Now x to the second, like term, they're both negative, so minus and then 12 when you add the numbers 5 and 7. And here they're both positive. I was making sure they were both positive, and then I'm not tired and made another boo-boo. 35 plus 12 is that 47? And then minus 60. So there we have that. Now, if you wanted to multiply it in a different order, you'd get the same answer. And you would go, hot diggity dog. So I have one last problem to do, right? And will the calculator help you focus? I don't know if it will. So this one, I have the foiling to do. And then I'm going to be able to add the 52 after I foil. So I first have to foil these together. So that's 15x to the second. If you need to, write it out. Minus 21x plus on the inside, 8 times 5 is 40, I think, x. A negative times a positive. 8 times 7 used to be my nemesis. 56, though. Plus 52. I don't know how many times I got that one wrong. Embarrassed to say, I think. So 15x squared. And then negative 21 plus 40. And I'm thinking it's 19. Oh, that's my favorite number. Plus 19x. And then minus 56 and plus 52. Is that 4? Minus 4? Great. So there we have that. And so a little practice with multiplying. what I always suggest people do, that we did multiplying in this section, and which was 4.5, and we did adding in 4.4. And I recommend that you go back and do some multiplying problems and some adding problems and mix them up. Because what happens on the test is that people add when they should have multiplied and multiply when they should have add, because they don't really have them down that well. And so I really recommend that you go back and do some problems in 4.4, and then do some 4.5, then do some 4.4, then do some 4.5 until you are freaking confident. Because actually most people can repeat the same process over and over again, but if they're then given an addition problem after they've been doing some multiplying, then they mess it up. And so I really recommend you mix it up so that you know, so that you don't just are repeating the same thing, that you absolutely are saying, I know what I'm supposed to be doing here. I'm supposed to be multiplying, or I'm supposed to be adding. Okay, so that's whatever it was, 4.5. And we did a lovely job on it too. It's beautiful. Tears to my eyes.